Well, YouTube, in this video we're going to solve an equation containing rational expressions, but in this video we're going to highlight an example that has two different solutions, or we're going to have to deal with maybe solving a quadratic equation in the end. So let's go ahead and get started. We notice here that I have some fraction equals a fraction plus some constant here. If we are going to solve this, then the first thing that I would attempt to do is multiply to get rid of the fractions on both sides. So I say, well, what is the least common denominator that I can think of between a 1, an x squared minus 1, and an x plus 1. Well, the first thing I want everybody to notice is that we can factor this denominator right here, this difference of squares. And so we say, well, this has a factor of x plus 1. What are the factors of this one here? Well, x plus 1 and x minus 1. And we'd say over here, we'd say this is a 3 over 1. So we say total factors here, what we want to multiply by, it looks like everybody's going to need an x plus 1 and x minus 1, okay? So if we were to multiply both sides by x plus 1, x minus 1. We'll do the same thing over here, x plus 1, x minus 1. We're going to distribute through by this least common denominator. I noticed that over here these would cancel out, and we would get left with x minus 1 times 4x plus 1. That's a 4 on the left side. Now, distributing this through, we have to distribute it through to both terms. Basically, we're going to get both of these to cancel. With this one here, we get left with just 12, which is kind of nice. And we say, now plus 3 times, and nothing cancels here. So we're going to have to say 3 times x plus 1, x minus 1. So now our method's basically going to be to simplify, and solve for x. That's what we want to do. So let's go ahead and FOIL the left side here. It looks like we get 4x times x is 4x squared. We get plus x minus 4x is really minus 3x, and we say minus 1. And on the right side, we have 12 plus. Now, I'm actually going to, I don't know, let's do this. Let's distribute the 3 through here first. We get 3x plus 3, x minus 1. And so on the left side, we have 4x squared minus 3x minus 1. This is 12 plus. Now we'll FOIL this. We say plus 3x squared minus 3x plus 3x. So those cancel. And then we would get minus 3 here, so minus 3. And so I notice I can combine these like terms. This is kind of a lot of simplification, but it's necessary. So we say minus 3x minus 1 equals, and we'd get over here, we get 3x squared, and a positive 12 and a negative 3 gives us a positive 9. So now, the real question is, could we isolate x? And I notice that we have both x's squared and x's to the first, so this is going to be an impossibility to solve with roots. So what we're going to do is we're going to set everything equal to 0 and solve this by factoring if we can help it. So I'm going to go ahead and subtract all of the things on the right here over to the left. So I would subtract 3x squared from my x squareds over here, and I'd subtract the 9 here from my constants over here. And what I end up with is 0 on the right side, so this all equals 0. And it looks like we get 4x squared minus 3x squared is x squared. The negative 3x we can just carry down, and we say this is negative 10. So can I think of two values that multiply out to be a negative 10 and add up to be 0? Because factoring is going to be our method here for solving. And I noticed that, if we were to take away 5 and add 2, those would multiply out to be our negative 10, and it would add up to be a negative 3. So since we get an expression now that two factors equal 0, we can basically say, then x minus 5 had to be equal to 0. Or x plus 2 have to be, that's got to be equal to 0. Somebody here had to be 0. So if we solve these, we basically get 5 and we get negative 2. So I do want to check both of these back in the original equation, because it's possible that maybe one of them doesn't work, okay? So when we check this in the original equation here, we'll say 4 times input plus 1 all over input plus 1. And this is supposed to be equal to 12 over input squared minus 1 plus, and I'll put 3 over 1. The first value that I'll plug in here is the negative 1. I don't know, I'm always suspicious of negative values here. And we say, well, if I plug these in, I basically get, up here I would get negative 8 plus 1, which is negative 7. And this would be, negative 1 down here. So I get negative 7 over negative 1, or 7, would be equal to, now over here, if we squared your 2, you'd get 4 minus 1 is 3. And so 12 over 3 is 4, and 4 plus 3 looks like we get 7 equals 7. So that works when we use negative 2. If I go back now and I change this negative 2 to our other solution, which is a positive 5, we would get up top, we would have gotten 21 over 5 plus 1, which is 6. So 21 sixths on the left side, 21 sixths. And on the right side, if we were to plug in, we're plugging in a 5. 5 squared minus 1 is 25 minus 1 is 24. So 12 24ths, 12 24ths, or half, plus 3 wholes. So is this 3 1/2 right here? Well, if we reduce both of these by 3, we get 7 halves, which is 3.5. And over here we get 1/2 plus 3, which is 3.5. So we do indeed get a solution with both of these. These are both solutions. But that would be an example of where you might have to multiply by a least common denominator that would present you with more than one solution. Cheers.